Okay, AZ Merits Review number 2. Write an expression. Circle that, please. Write an expression of the sum adding up the first 16 terms in this sequence. So even though there's just not enough room here, so I am going to write in the box. Remember, for your AZ Merit, you should only put your answer in the box. This is the general equation, just to do a quick review with you. This is the general equation you're going to want to use. The a sub 1 represents the first term in the sequence. The R is referred to as the common ratio. It means how did you go from one number to the next consistently. And N represents the number of terms you want to add up, starting with the first term. So we want to add up the first 16 in this case. How do you find the R? You can find the R by taking the second term and dividing it by the first term. We get an answer of 4. So in this sequence, which is geometric, we can go from one term to the next by multiplying consistently by 4. What would this answer be? The expression would be, for this case, 3 times the quantity, 1 subtract 4. The 4 on top is going to be raised to the 16th power. If that's all they asked, you'd be done. Just for additional practice, what if they said, evaluate this. What is the sum of the first 16 terms? Grab your calculator. You're going to move with me through this pretty quickly. 1 subtract 4 raised to the 16th power. 1 subtract 4 raised to the 16th. That time I did it right. Let me move this off to the side so you can see. Then we're going to divide it by, in parentheses, 1 subtract 4, end parenthesis. Take it times the initial value out front of 3. And here's how you would write the sum of the first 16 numbers if that was the question. Please start that problem with a highlighter if you feel like you should go back and review that general equation before the exam. Number 2 says, write an expression that represents the 13th term in the sequence. And as a review, this is the formula. Now, I do want to go over a common misconception. The common misconception is, I've heard students in previous hours today say, Miss, isn't this the formula that I just circled? Isn't this the formula I used to find a term? That's correct for an arithmetic. Remember, the difference between arithmetic and geometric is arithmetic would be like this, 2, 4, 6, 8. You're increasing consistently by adding or subtracting the same number. Geometric is you're increasing or decreasing by either multiplying by the same number or dividing by the same number. In this case, we are multiplying by 4 consistently. It is geometric, and this is the formula you should use. So what is the expression? The first term, the common ratio, how do you get from one number to the next? And then n subtract 1. 13 subtract 1 is 12. That's the expression. But just for more practice, what if they said, please tell me the 13th term in this sequence? Grab a calculator. Again, if you don't have one, go grab one. You have 10 seconds to get the answer, check with your partner, and then look up at the screen and see if you're correct. Bless you. $50,331,648 is the 13th number in this particular sequence. In my opinion, your class and classes in past years, they don't have any trouble when they're given the formula and they just have to plug numbers in and get an answer. It's memorizing these formulas that they struggle with. And so if that's your case, please make sure to star these so you can go back and review them. Number 3. We're given a logarithmic equation and we want to transfer it into exponential. Remember, exponential, when we first started learning this, we put boxes down. And as a quick reminder, yes, you can use the disco move, but since I am filming this, it's hard to see the disco move here. I'm going to go over a method a teacher on this campus uses. They said this is the base. Then I'm going to go underneath the entire problem. On the opposite side of the equal sign, I'm going to push this quantity up. And I'm going to set it equal to this number, which happens to be 17. 2 raised to n minus 5 equals 17. Now, after you've done this, you could use the disco move to check and see if you're right. So 2 raised to on the opposite side, n minus 5 equals an answer of 17. That is correct. Going down to number 4. Number 4 looks slightly different on my paper than yours. And that is because I made an initial mistake when I first copied this, and I have a 43 instead of 42, which you have on your paper. I want to review something with you. Gabby, choose the number 10 through 20 that's even. 14, okay. Everybody look at this. This is going to relate to number 4, but it's not number 4 itself. If I said 2x equals 14, and I said solve, in your head you divide by 2, and the x equals 7, right? But there's another way to represent this or get the answer that does not involve directly dividing. Another way to do this is 2 is on the bottom. So I could write it as 14 times the quantity 1/2. 1 over this number. What's half of 14? 7. We still get the same answer. Does everybody see that? That's going to relate to this problem and a future problem today. So again, what you need to change is wherever you see a 42, you're going to change it to a 43 on your paper. Okay, let's solve this. I'm going to write small. Let's see if I can zoom this in for this particular problem and zoom out afterwards. So I know 40 subtract 18 is 22. A lot of steps to this problem. If you see me make a mistake, please holler out. Now let's start by trying to isolate the e. Remember, that's Euler's number. So first I'm going to add 12 to both sides. When I add 12 over here, I end up with 86. Now I'm going to divide both by 22. Inverse operation leaves me with 86 over 22 equals e to the negative 0.25x. I can see that they're both even, so I'm going to grab a calculator and take 86 divided by 22. I'm going to let the calculator reduce this for me, and it reduces down to 43/11. 43 over 11. Okay, now I want to eliminate the e so the negative 0.25x falls down. To do that, I'm going to do log base e on both sides. I want to apply that log base e to the 43 over 11, not just the 43. Bless you. On the right-hand side, the purpose of doing this is so the log base e and the e cancel, and I bring down the negative 0.25x. When I look at my choices, I haven't done anything wrong yet, but I don't see any log base e. What is the equivalent form of log base e? So ln of 43 over 11. My last step will be to divide by this negative 0.25. So I'm going to divide both sides. I'm running out of room, so I'm going to come off to the right here. I have ln. I'm applying that to the quantity, 43 over 11 equals x. And let's divide this whole thing by negative 0.25. Nothing that I've done is wrong, but when I look at my choices, I don't see that exact answer. I do know that I'm going to have an ln, so anything that doesn't have an ln, I'm going to cross out. It's not A, C, or E. Now let's go back to what's a different way I could represent this. So I could represent this as 1 over negative 0.25 times the quantity ln of 43 over 11 equals x. That answer does exist. That answer exists in option D. I've had students in the past say, Miss, but the negative sign is in the middle. It's not down below. It doesn't matter where the negative sign is as long as only one exists, and the original problem only has one negative. Okay? Moving on right now to number 5. So number 5 is similar to number 3. We're doing the opposite operation. This time we're given exponential. We want to go to log. So let's put our boxes in place. The base of this particular problem is the number e. Remember, we go across the problem. And whatever's on the opposite side becomes the exponent. In this case, it's 2x plus 1. and we go backwards to get the answer. In this case, it is 7. And you could definitely use the discal move to prove this. Okay, e raised up to the 2x plus 1 equals 7. That's exactly what we have. Make sure to star 1 through 5 anything you know you should go back and review. Then flip and find number 6. I know I'm going really fast to get this all filmed. Can you give me a 1 through 5 in your understanding so far? Totally fine to be a 1 or 2. Most of us are 3 or above. Okay, next one. Let's solve here for x. So I know I want to isolate the 10. To isolate the 10 and then eventually get to the x, I need to start by getting rid of 18. Please help me out. Take 720 and divide by 18. 40, thank you. Let's use best test practice. Let's see if I can eliminate anything. So 40 equals 10 raised to the x plus 3. Okay, that's here. My fault. That's here, 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 and here. Cannot eliminate anything yet. Now to get rid of the 10, I need to do log base 10 on both sides. It's known as the common log. Remember, your calculator can only evaluate in common log, that's base 10, or base e. Why did we do this procedure? This is the only reason why we learn logs. And the purpose is, now I cancel this out and I bring down the x plus 3. When I rewrite this on the left, I don't need to put the 10 there. When you don't see the base as a number, it's a hidden 10 every time. This log is only going to be applied to the 40, so let's put it in parentheses. The final step is to eliminate the 3. Inverse operation would be to subtract it. And my answer is D. My answer is D, not A. Again, this log only applies to the 40. After I would evaluate that, then I would subtract 3. I don't combine what you may perceive as like terms. Going on to number 7. Please change the number 7. I think yours says 32,000. Change it to 92,000. Okay, with your partner, you're going to do this problem at the same time I do it. This is a tricky one, but I want to review with you one thing. How many remember when I say this, change the base formula? How many remember what that is? Change the base formula. Okay, here we go. One person, look up here, please. If I gave you this, could you immediately get an answer on your calculator? Is this base 10 or base E? This is base 10 because it's a hidden 10, right? So let's look on your calculator. You could go, okay, I see log. I see the log. That means it's a base 10. I could do base 10 of 7. I get an answer. Problem's done. What if I did this one? Could you get an answer? Yeah. Because we do have a log base E. What's that called on your calculator? That's the same thing as this. So these kind of problems were wonderful. But what about this? This is not a log base 10, and it's not a log base E. So when we have this situation, we do something called change of base. It allows us to use the calculator to evaluate this. To do this, we do log of the back number divided by log of the base. It's not the log of the bigger number or smaller number. Log of the back number divided by log of the base. Now what is the base in these two problems that we can't see? A 10. And can we evaluate with a 10? Yes. Okay, with your partner, you're going to go through talking through number 7. I'm going to do the problem at the same time. Your goal is to be done in 30 seconds. Begin. First, you have to apply the log to the 200 before you can divide by 5. Cannot take 200 and just divide it by 5. Likewise, we can't take 40 and just subtract 3. We have to apply the log first. How many of you were able to understand an answer of C, just so I have an idea? Okay, we're going to move on to number 8. Number 8 is going to take us 3 to 4 minutes to do. I know this sounds simple, but I quietly want you to read just this line to yourself twice. So when I ask you a question, you understand what just this line means. To yourself, quietly go. I know m of x is an exponential equation because we have a variable in the exponent position. Do you remember how exponential equations look like this, like that, or like this? Remember that, guys? Okay. In this case, do they ever have an x-intercept? The only way they have an x-intercept is if you take this thing and you shift it in a certain direction. Well, we're actually going to shift it up 3. So let's just draw just a general idea of what this looks like. 1, 2, 3. This is like our new horizontal asymptote. And this equation is going to look something like this. We're going to graph it in a little bit. But does this ever have a y-intercept? Yes. But does it ever have an x-intercept? No. Just so we know that. Here's the question consistently students cannot answer today. Do not overthink this. This is exponential because it has a variable in the exponent position. What is this function? Anybody? This is the function n of x. What did it tell you about n of x? Okay, circle quadratic, draw an arrow. So we know for a fact it's quadratic, but we don't have an equation. So there's different things we could do to come up with an equation, but that would be way too much work. Remember, I'm a lazy math teacher. So, well, not really, but I'm lazy when I can use the calculator, okay? Do second plus 7, 1, 2. Go to stats. Go to edit. Please type in these numbers. If you happen to have a calculator that does not say L1 followed by L2, you need to exchange it for another calculator. Once you have the numbers in place, we know it's quadratic. We can do something that's called regression. Regression says, hey, you know all these data points? Give me the data points, and regression model says I will actually give you an equation that matches those points. So to do that, hit Stat, go to Calculate, and go down until you find Quadratic Regression. That's abbreviated. Now, you may have a newer model calculator, like mine, or you may have an older one. The older ones are simple. You press Enter twice, you get your answer. Mine have to press like 5 or 6 times until it calculates. But we all should get the same answer. What does this mean? It means our answer is y equals 2x squared. You could definitely say plus 0x, but what's 0 times anything? So I'm not going to write that down, but you could. Plus 4. Here's my first equation. It is exponential. Here's my second equation. It is quadratic. Go to y equals, and we're going to plug this in. If you already have something there, please do second plus 7, 1, 2. I want to show you mistakes students are consistently making. If you can just glance up here really quick. Watch me quickly plug in the first equation. 2s plus 3. Why is this wrong? I plugged in 2 to the x plus 3. Why is this wrong?
Because it's plus 3 afterwards, not...
Plus 3 is the vertical shift. It's not part of the exponent. So here's a way to get around this. We could go back, and I could tell you to use arrows to get down here. But what I tell students is put that number in front. 3 plus 2 raised to the x. My next one will be 2x squared. If you want to put plus 0x, it's not going to be wrong. Plus 4. This is my first, remember that. This is my first equation. This is my second. When you're done, hit graph. Here's the first one. Do you see how it's gradually going up as you go to the right? And my second one is a parabola. So we are going to, you may have to slightly change yours. I have forgotten if I changed these. You may have to slightly change yours. We'll go one by one. It says both equations are going down from -3 to -1. So if I zoom in here from -3 to -1, let's look at the first equation, which, I'm sorry, you can't see anything. There we go. Let's look at the first equation. That's this one. This first equation. From -3 to -1, is it going down? Is this equation going down from left to right? No, in fact, it's going up. We're selecting all that are true. It said both of them are going down, decreasing from left to right. The next one says the x-intercepts of the first is greater than the x-intercept of the second. Does this first one have an x-intercept? No, so that's not, we can't even compare that. They don't have x-intercepts. The third one says, and I'm going to slow down for this one. It says all of your y values, please write values above this, all of your y values are greater for the first equation than the values of the second equation whenever x's are greater than 0. So whenever I have an x value that's positive, these values will always be greater than the second values. Okay, you ready? Do second graph. The first x value in this chart that is positive is 1. Part B says m of x, this is the y values for m of x, here's the y values for n of x, says that the y values for m of x will always be greater than the y values for n of x. Is that true? Because 5 is not greater than 6. As soon as you find one point in which it's not greater, we say it's a false statement. Do not do this on your calculator. I just want to show you on mine. Please look up. Whenever you find a y-intercept, remember your x value is always, what is the x value for all y-intercepts? Okay, so just now keep where you were. The option D says that the y-intercept for both functions is the same. Is that true? Yeah, in fact, they're both have y-intercepts of 4. So circle D. Option E is almost identical to option C. It says the values for the first graph will always, it says the values for the first graph will always be greater than the values for the second graph when you have negative x's. So the first negative x we can look at is -1. You have to use the cursor and go up. Is it true that the y values for the first are greater than the y values for the second? Yes or no? Some people are like, yep. Some people are saying no. Turn to your partner. In this particular example, is this a yes or no? No, because 3.5 is not greater than 6. This is your y values for m. This is your y values for n. Cross it out. M and n are increasing where x's are positive. Go back and hit graph. So I'm only focused over here. Are both of these functions increasing from left to right? Are they both going upward? Please circle F. I will tell you that this particular problem was taken from the practice test of AZ Merit, which in my opinion probably means that there's going to be a problem just like that on your test. So I would probably start even if you're like, I get it. I believe number 9 and number 10 I changed. I believe number 9 and number 10 I changed. Number 9, which expression represents the sum of the first 23 terms in this sequence? Okay, so sum. Remember we start with the first number, which is 6. Then it's 1 subtract 1 subtract. And to find the r value, I can do that. I know this is geometric because I'm consistently going up by multiplying by 3. Your 3 is your r value. I got that by taking 18 and dividing it by 6. And I want to find the first 23. This option is option C on my paper. This is option C on my paper. Like I told you, I think number 9 and number 10, you need to change some things. Number 10, which expression represents the 23rd term? We don't want to add up the first 23, the 23rd term. So we start with the first term in the sequence, which is 6. Then we have a common ratio of 3. And remember, it's not a 23 up here, it's an n minus 1. 23 minus 1 is 22. This expression can be found in option D. Okay, you have with your partner 25 seconds to get the answer for number 11. I'll do it at the same time. Actually, I'll do it afterwards. 20 seconds, begin. Can I directly plug this into the calculator like it is? No. So I need to do change of base. Log of the back divided by log of the base. Then I'm going to subtract 2 to get x by itself. And this answer comes in option D. Number 12. It's been a while since we've done problems like this. Remember, because it's greater than 1, we know it's growth. In fact, the growth rate is 6%. This is the amount of money you invest. This is the time that it stays in. And it tells us that this amount is within hundreds of dollars. So what does 3.2 represent? It's the amount you invested in hundreds of dollars, which is option D. Go on to 13. The population of a town is currently 6,000. It's expected to triple every 5 years. What will the estimated population of this town be after 25 years? Here's the initial population. Your growth rate is tripling. It occurs every 5 years. We can evaluate this problem for this particular incident by putting 25 in for x. So I know 25 divided by 5 is 5. So in my calculator, I do 3 raised to the 5th power, and then take it times 6,000. So in 25 years, we can assume that the population of this town would be close to 1,458,000. Please go back on 9 through 13 and put any stars next to things you should review. You're going to have a chance to review today, so I want you to start it today. Yes, Frankie, go ahead. That's a great question. For the AZ merit, I think it will say if you have to write a statement. So if it doesn't say a statement, then I think you could just put in a number. Like, I assume if it's this problem, it's going to be where you bubble in the answer or you select. Okay, good question. Unfortunately, we never get to seem to know. We're told that you have to be prepared for that, writing the statement. Okay, this looks more complicated than it really is. Okay, you ready? So, I want one person to read it. Pay close attention to what the symbols mean and what we're getting down here. Okay, ready? Begin. With me, I would hope on a test you're taking your time, you're focusing. So, ready? Miguel's driving. Scary. He's sitting on 3 pillows. He's driving. You can see over the wheel, and steam starts coming out from the engine. Right? It's overheating. What is the temperature of the engine right now? 280. 280. I agree with you. Circle this. Draw an arrow to T sub 0, the initial amount. T sub r says what is the temperature surrounding. So outside of the engine, what is the temperature in the air right now in this problem? It's 80 degrees. The temperature outside surrounding the car is 80. Wherever you see a T sub r, put an 80. Your R is a rate. Now be very, pay close attention to this. Do you see how there's a negative sign in front? If you had a problem like this, which on the test, they would provide you with this formula. They would tell you what is T sub r and T sub 0. What I mean by that is they're not going to say t sub 0 is 280, but they're going to tell you up above what do the variables stand for, and then they give you a word problem to plug it in. So what I'm trying to tell you is you don't have to memorize this particular formula, okay? All right, the next thing is we want to know when is the car going to cool down to 230 so Miguel can start driving again. Okay, I did not provide you enough room, so let's write inside the box for today. Know that for your test, you're only putting answers here. 230 equals 280 subtract 80, and then e raised to the negative 0.0048t plus 80. 280 subtract 80 is 200, so now I have 230 equals 200 e raised to the negative 0.0048t plus 80. Use a calculator or do it in your head, please. Subtract 80 from both sides. What do we end up with? 150? 230 subtract 80. Is that correct? 150. 150 equals 200 e raised to the negative 0.0048t. Okay, I'm going to divide by 200. Please do the same on your calculator. If you get a terminating decimal, that means a decimal that stops, we can just write the decimal down. If not, we'll turn it into a fraction and see if that's possible. Which it will be because it's coming from a fraction. Do you get 0.75? So now I have 0.75 equals e to the negative 0.0048t. Once again, e is a number, Euler's number. So to get rid of it, I'm going to do log e. What happens to the log base e on the right? They cancel out with the e, that's the whole purpose. And we bring down negative 0.0048t. And then on the left-hand side, what's another way I can represent log base e? So ln of 0.75. Now my last step will be to divide by negative 0.0048. And we're going to grab a calculator. And I'm going to type in ln, because there's no log base e, ln.
Can you just allow my kids to come in? I just got to meet with Calvin. So just let them come on and we'll be fine. All right, thank you.
ln of 0.75, get an answer, then divide it by negative 0.0048. It says to round to the nearest minute. So approximately how many minutes will it take for the car's engine to go from 280 degrees to 230 degrees if the temperature outside is 80 degrees? Approximately 60 minutes. Now, what if this was AZ Merit? And can everybody glance back, and I believe it's number 4. Look at number 4 in the first page. Was number 4 multiple choice, and there's like 6 options? What if it said, which expression represents how many minutes it would take the car's engine to reach 230? Well, you may see this, look up here please, you may see this as an option, but if this option wasn't available, you may also see this, ln of 0.75, and then how could I represent this? 1 divided by negative 0.0048. Make sure your partner understands both ways in case it was an expression that was asked for instead of an answer. Thumbs up, thumbs down for that problem. Thumbs up, thumbs down so I can see. A lot in the middle, some up. Okay, let's go on to the next one. I'll read this just for time purposes. We have 8 minutes left. I want to get done. We have 2 functions below. Only one solution to the equation occurs when we know c is 2. Please circle the value of x, because that's what we want to find. So we know c is 2. So I'm going to go wherever I see a c, I'm going to replace it with a 2. Grab your calculator, please. Do second plus 712. In the first one, I'm going to do 4 to the 4 squared. In the second equation, I'm not going to do x raised to the 2 plus 2. I'm going to do x raised to the 4th power. way, I know that 4 squared is 16. And whenever you have an equation such as y equals 16, y equals any number is a horizontal line. And this one's going to occur at 16. So when you hit graph, you're only going to be able to see one function. And here's the reason why. Hit Windows. Go to the y maximum. Can we see 16 right now? We can only see up through 10. So let's change it and make it up to like 25. Now hit graph. There's the line y equals 16. There's the second one. How many intersection points do you see? Do you remember how to do second trace intersect? With your partner, you have 30 seconds to get 2 intersection points. Begin. How many of you had 216 and negative 216? Those are your two. Does anybody want me to show you how to do it on the calculator? Okay, here's the deal. They're only asking for the x values. So what would be acceptable answers? What if you chose to bubble in 2 and your partner bubbled in negative 2? Who would be wrong? You got it. Go on to the next one. This is in honor of Miss Castro. I don't know if you guys know, but she's leaving teaching. And she's going to open a car business. Do you guys know that?
No.
You're gullible. Okay, here we go. One person reads it, go. So how much does this equation show that the initial amount is? 1,800,000, right? I know that they're making money, not only because I read the problem and I can see that we're going up, but I know they're making money because it's greater than 1. Okay? So what is the growth rate here? It is 3%. But that 3%, please write 0.03, that 3% is only applied, that's per year. Does everybody see per year here? We want to know per month. Well, I know there's 12 months in a year, so let's split that up. Let's do 0.03 divided by 12, and then we can turn it back into a percentage by moving the decimal 2 places. So if we move the decimal 2 places to the right, what do we end up with? 0.25%. And you're like, that seems crazy, Miss, that seems way too small. Well, think of it this way. If we took 0.25 and we added it 12 times, because there's 12 months in a year. Let's take it times 12. Do we end up with an answer of 3%? Yes. Does everybody see that? Okay. So 0.25% is the answer. We want to write this right now, 0.25, in here. So 0.25.